Now we're going to talk about how to count in other number-based systems. So other systems besides base 10. This is really going to push your understanding of what place values truly mean. That's why we cover this. Not that you're going to be teaching this in elementary school, but it's to deepen your understanding of place values. So think about what you've known all along about base 10 numbers. You know that there's only 10 symbols that we can use, 0 through 9. 9 I've got highlighted in red because it is important. What happens when you get to a 9 or once you get past a 9? So we start, these are what our place values indicate, ones, tens, hundreds, thousands, 10,000s, and we end at 9. So I put 0 as a placeholder. We start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and after 9, we just know this instinctually, it suddenly rolls to a 2-digit number. And it goes 1 with all of the other symbols. So 1 with 0, 1 with 1, 1, 2, 1, 3, 1, 4, 1, all the way up through 1, 9. And then after 9, we have to roll again, and now it goes to 20. And then you put a 2 with all the symbols, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, up through 2, 9. After the 9, it rolls that first digit up another one to a 30, 31, 32, 33, 34, and it goes like this up through all of the 40s, 50s, 60s, 70s, 80s, and up through the 90s, 98. Once you get this terminal symbol twice, 99, that's when it now rolls into a 3-digit number. And it doesn't roll into a 4-digit number until we get to 999. Then it rolls to 4 digits. So it's important to notice that 9 is sort of when that rollover happens. Okay. So let's use that same idea with base 6. So with base 6, you see how I changed the base from 10 to 6? So you've got 1s and 6s and 36s, etc., etc. I don't know what all those are off the top of my head. But its base is 6. So there's only 6 symbols you can use. So you can only go up through 5. Base 10, there are 10 symbols. Base 6, there are 6 symbols. Everybody always forgets about the 0. So it doesn't end at 6, it ends at 5. So 5 is going to act like your 9. So notice when you count, you go 0, 1, 2, 3, 4. When you get to 5, now suddenly we can't go on to 6. 6 doesn't exist. We got to roll to 1, 0, 1, 1. 1, 2, 1, 3, 1, 4, 1, 5. Up, there's a 5. It's going to roll. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. It's going to roll again. But we don't call it 30 because that's specific to base 10. We call it 3, 0. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. Oh, it's going to roll again. 4, 0, 4, 0, 4, 1, 4, 2, up through 4. Now when it gets to 55, that's like 99. It's your terminal symbol twice. Then it's going to roll into 3 digits after 55. So I want you to see what's happening is all of this part is getting cut off of the table. And any rows that would have had like 60s or anything with 6 or bigger would get cut out. And that would be your system. It's a little different. It rolls faster than what you're used to. Let's look at base 5. There's only 5 symbols we can use. 0 through 4. 4 is now going to act like a 9, so we can't go above 4. So you see how I cut out another column? Once you get to 4, that acts like a 9. You roll into 2 digits. 1 with all the symbols, 2 with all the symbols, 3 with all the symbols, 4 with all the symbols. Oh, 4, 4, that's like 99. It's going to roll to 100. Maybe I should have circled these over here also. Let me go back and add circles here. That's when you're rolling to more digits. Okay. Base 4. Well, now it's going to roll even faster because now our terminal digit is going to be a 3. So you can't go above 3. So see how much shorter it is? So after 3, we roll to 1, 0, 1, 1, 1, 2, 1, 3. Roll again. Go through all the 2s. Roll again. Go through all the 3s. When you get to 33, that's like 99. Then you go into 3 digits. So I want you to see kind of the pattern here. Now the next one is base 3. Base 3 is going to roll even faster. your terminal symbol that acts like a 9 is a 2. So when you get to 2, you got to roll to 2 digits. So you put a 1 with all your symbols, and you put a 2 with all your, and you already are up to what's equivalent to 99. And then that's going to roll you into 100, 101, and then it's going to cycle through again. When you get to binary, that's base 2. That's only zeros and ones. It's a computer language, right? It's all binaries. It's all zeros and ones. It's extremely difficult because the 1 acts like a 9, and you just constantly roll over all the time. So I find binary, actually with less symbols, it's actually harder to work with. That's just my opinion. Then I want to talk to you about base 12, because I like to throw in these bizarro bases. So what do we do in base 12 when we work in base 10? We don't have more symbols. We can go 0 through 9, but how do you put a single digit symbol for 10 and for 11? Because we can't put 1, 0. We can't combine symbols. We have to have a single thing. So they use a T and an E. And depending on where you go on the internet, this is going to be different in different places. But for your textbook, they use a T and an E. So the T stands for 10. The E stands for 11. So that's going to act like your 9. So look at this. This actually made the thing bigger. 0, 1, 2, 3, 4, 9, T, E. It doesn't roll until you get here. Then you roll to 2 digits. A 1 with all the symbols up through T and E. A 2 with all the symbols. 3, 4, 5, all the 9 with all the symbols. A T with all the symbols. An E with all the symbols. And then finally when we get to EE, that's like 99, then it rolls to 3 digits. So this one, it takes longer to roll than what we're used to. So it's, you know, other bases are kind of strange. It's really kind of hard to work with other bases, but just try to treat them like we treat our number system, and maybe that'll help. So let's see if we can practice finding what comes before or what comes after a number. And these are base 5 and base 6, so I'm going to kind of push this so we can see base 5 and base 6 here. What number comes before? What number comes after? Okay, let's start with this one. What number comes before? What you want to think about is how many symbols do you have in base 5? Okay. The only symbols you have are 0, 1, 2, 3, and 4. And this 4 is going to act like 9. Okay. That's what 4 is going to do. 4 is going to act like a 9. So this is the way I do it. I treat it like something I already know, and then I adjust it. So I just say, okay, what number comes before 40? The number that comes before 40 is 39. We all know this, right? The problem is there's no such thing as a 9 if you're in base 5. So we can't have a 9. It has to be replaced with a 4. So the number that comes before 40, base 5, would be 34, base 5. And let's see if we can see this one on the chart. So here's base 5. Here's 40. What number comes before it? 34. You can see it right there. 34 is what comes. Base 5, you got to make sure you put the base 5 on it. If you don't write that little subscript with the base, we assume it's base 10. You don't want to do that. So I just pretend it's base 10 and then adjust. So I thought it was 39, but we don't have 9s, we have 4s, so 34. What number comes before 320 base 5? I'm like, oh, well, it would be 319, right? Oh, but we don't have 9s, we have 4s. So it would be 314 base 5. Now that one we can't check because I didn't do enough numbers on the table. But you can trust me, that's the number that comes before it. So now to do the number that comes after, it's kind of a similar concept. This one I asked base 6 numbers, so I'll move this so we can see base 6. What number would come next, right? So remember in base 6, there's only 6 symbols, 0, 1, 2, 3, 4, and 5. 5 acts like 9. So 35, right, or 35 base 6, that's a whole lot like saying 39, right? In base 6 language, the 5 acts like a 9. So to me, it reads like a 39. Well, what comes after 39? 40. And 40 base 6, let's see if we can see this one. Here's 35, right? 35, sorry, I should call it 35. What comes after? 40. This one you can see in the chart. But I want you to understand why. It rolls. That 5 acts like a 9, and so it's going to roll. So what about this one, 555? Well, if you're just repeating the terminal symbol here, 555, that reads to me like 999. And I know what comes after 999, it's 1,000. But this is base 6, so it's really 1000. We don't call it 1,000, 1000. So that's how I would handle those. I would try to treat them like 9s when you can, and know who acts like a 9 depending on the base. All right, so to end this video with some easy questions, these are ones that are so easy they're hard, and students always overthink them. It says in the instructions, what base 5 number is shown in the base 5 block picture? So what base 5 number in the base 5 block picture? These are 1s and 5s and 25s. They're 5 by 5, so those are 5 squared. And these are 5 cubes, 5 squares, 5 little flat or little skinny ones, sorry, and then you've got your 1s. So 1s, 5s, 25s, and 125s. Okay, when I call it 25 and 125, I'm using base 10 language. We're trying to keep everything in base 5. So in base 10, each shape represents a place value. It's the same thing for base 5. All you have to do is look at it and literally count the number of shapes. This is a 4-digit number. You have 3 of those, you have 2 of those, 4 of those, 3 of those. The number is 3, 2, 4, 3, base 5. That is it. Please don't make it harder than that. Okay, you're literally just reading and saying that the shapes tell you what's in each place value. Now, if you start counting every little individual square, you're going to tell me the base 10 number. It didn't ask for that. I want you to stay in base 5. So it's literally 3, 2, 4, 3, done. So then what would this be for the base 2? Right, this is your 1s and your 2s and your 2 squareds and your 2 cubes. See, it's like a cube. We actually don't have any flats here. So again, how many shapes are you listing? There's 1, none, 1, 1, 1, 0, 1, 1, base 2. That's it. Don't count individual squares. That's not what they're asking you to do. You're staying with base 2 blocks. What base 2 number is shown, you answer with base 2. Just list the number of shapes. 1, 0, 1, 1. Done.